Okay, for this lesson, we're going to take a look at our last method for how to algebraically solve quadratic equations. We're going to do this using what's called the quadratic formula. So to begin, we're going to take a quick review of the methods we've learned so far. So the first one is not algebraic, but we can solve it by graphing this equation into our calculator. We're going to replace the 0 with y and say that we have 3x squared plus 5x minus 2. I can use my standard window settings, negative 10, positive 10, 1, negative 10, positive 10, and 1. I'm going to draw a little sketch of what I see. And it's going to look something like this. And then I have the two x-intercepts I'm going to solve using the zeros function or roots function on my calculator. And I see that, in this case, x is equal to either negative 2 or 1/3, the points where you cross the x-axis or the x-intercepts. I can do this by factoring, and I should get the same answer. If I have 3x squared plus 5x minus 2 is equal to 0, I'm going to split up that middle term, the b, and I'm going to get 3x squared plus 6x minus x minus 2 is equal to 0. Factor by grouping, and I get 3x and x plus 2 and negative 1 and x plus 2 is equal to 0. Or x plus 2 and 3x minus 1 is equal to 0. And I have two possibilities. Either x plus 2 is equal to 0, which means that x would equal negative 2, or 3x minus 1 is equal to 0, 3x would equal positive 1, x would equal 1/3. And I still wind up getting the same solution, negative 2 and 1/3. I can do it by completing the square. So I'm going to start by grouping together the x's. 3x squared plus 5x minus 2 is equal to 0. I divide out the a value, 3, and x squared plus 5 over 3x minus 2 is equal to 0. 3x squared plus 5 over 3x, and then I take 5 over 3, divide it by 2, and square it, and I'm going to get plus 25 over 36 and minus 25 over 36. Minus 2 is equal to 0. 3x squared plus 5 over 3x plus 25 over 36. And I'm going to move that negative 1 out, so I'm going to multiply it by 3. So I'm going to get negative 25 over 12. And I can put this negative 2 as a fraction over 12, so it's going to be negative 24 over 12 is equal to 0. Or 3, I take the square root of this, x plus 5 over 6 squared minus 49 over 12 is equal to 0. Then I'm going to start actually solving it. So I'm going to move that q value over, 3 and x plus 5 over 6 squared is going to equal positive 49 over 12. Divide both sides by 3. X plus 5 over 6 squared is equal to 49 over 36. When I take the square root, I need to remember to take the positive and negative square root, plus or minus the square root of 49 over 36, or plus or minus 7 over 6, because they're both perfect squares. And then I have my two possibilities. Either it's going to be x plus 5 over 6 is equal to positive 7 over 6, or x plus 5 over 6 is equal to negative 7 over 6. In this case, I'm going to get, when I move that 5 over 6 over and subtract it, 2 over 6, or 1 over 3. And in this case, I'm going to get negative 12 over 6 which is where I get my -2. And once again, my answers match. Now, if I use the completing the square, but I'm just doing it with variables, I can come up with a new formula that I can use, which just jumps past the steps of completing the square because it's already used the steps that I've already done. So if I'm doing this, then I'm going to start with grouping. I'm going to say that bracket ax squared plus bx plus c is equal to 0. Group together the x's like we did in the last example. Divide out the a. X squared plus b over ax plus c is equal to 0. A bracket x squared plus b over ax. I divide b over a by 2, so I get b over 2a, and then I square it, and it's going to give me plus b squared over 4a squared minus b squared over 4a squared plus c is equal to 0. A bracket x squared plus b over ax plus b squared over 4a squared. And then when I move it out, I got to put the c over that same -4a. In this case, I don't need squared because I'm going to get rid of one of the a's when I multiply that -b squared minus 4a out. So I'm going to say that it's going to be negative b squared. I'm putting this all over 4a squared. And then for the c, to give it a common denominator, I'm going to say that's going to be minus 4, sorry, not squared, just 4a, minus 4ac. Because I got rid of one of the a's when I multiplied this out. And that's equal to 0. And now I'm going to solve it like we did in the previous case. I'm going to say that, oh, sorry, I missed one step. I got to take the square root on the bottom. A bracket x plus b over 2a squared minus b squared minus 4ac over 4a. Now I'm going to solve it. So I'm going to move that q value over, and remember the q value is made up of all of this. So when I move that q value over, I'm going to get a bracket x plus b over 2a squared is going to equal positive. And so now it's going to become negative b squared minus 4ac over 4a. I'm going to divide both sides by a. X plus b over 2a squared is going to equal negative, sorry, positive. What am I doing? B squared minus 4ac over 4, and because I'm dividing by another a squared. And I'm going to take the square root of the top and the bottom. X plus b over 2a is equal to the positive or negative square root of b squared minus 4ac. All divided by the square root of the bottom, because they're both perfect squares, is going to be 2a. And lo and behold, we have a common denominator already when we move this across. So x is going to equal, because it's over a common denominator, I can just subtract the b on the top from both sides. Square root minus 4ac over 2a. And we have a single equation a single formula to solve for what x is if I know the a, b, and c values. So with a quadratic formula that x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, the big thing is, first, just like in most other forms, it needs to be in general form in order to start this, so we can correctly identify what the value of a, b, and c are. Then we're going to substitute those values into the formula, and then prospectively, either we'll be able to simplify the formula, or if what's inside the radical is a perfect square, we can actually solve what the values are. It just is the difference between them being rational versus irrational solutions. So, for the first step, all we do is we make a list of what is my a, what is my b, what is my c. Well, here a is 1, b is negative 4, make sure you include the signs, and c is 1. So I'm going to say that x is equal to, and what I usually do is I just leave empty brackets where all the variables go, and then just fill in afterwards. And the pattern is that my b goes in the first two, negative 4 and negative 4. My a goes in the next one, then c, and then a down at the bottom. And now we're going to start by simplifying the top left. Just inside the radicand, don't put the square root into your calculator and what's in the denominator. So I can say that x is going to equal negative 4 is positive 4, plus or minus negative 4 squared minus 4 times 1 times 1 is going to give me 12. All divided by 2. Now, because 12 is not a perfect square, all I can do is simplify the radical and then simplify this fraction. So I'm going to simplify the radical. I'm going to simplify the square root of 12 into its mixed radical form, 2 root 3. You can do this by doing a factoring tree or just by dividing out perfect squares and simplifying over 2. Then there's 3 terms, and I need to see if there's a common factor between all of the values that are outside of the radical. You can't include what's inside the radical. So between 4, 2, and 2, they can all be divided by 2. And x would equal 2 plus or minus 1 root 3 over 1. And I can get rid of the redundancies and say that it's going to be 2 plus or minus the square root of 3. And there's my solution.